So good morning, my name is Mr. Kinyanjui John. I am a software developer, and for today we are going to do something fun. We're going to be creating a desktop calculator or a desktop based calculator. So what we had done prior is we had created the user interface. What we expect to do now is just add the functionality to the calculator. So all the buttons that we have currently, we make them functional, we make them work. So welcome to the session, and let's have fun together. Now, we are using Java and we are using a library that is called Swing. So with Swing, what we had done is we had created the entire user interface of the calculator, the entire shell or the skeleton. So the only thing left was to implement now what we normally call event handling. So with Swing, normally when we implement event handling, what we have is we have an interface we call Action Listener. Action Listener is the one that is responsible for helping us in handling these events. Action Listener, according to the rules of interfaces, has a single method which we must override. So all the way down here, there is a method in line 121 that is called action performed. So that is the method we're going to be using hand in hand to be able to implement the actions. The other thing, we have a single text field, and the work of this text field is simple. Just display any calculations that are currently taking place. The other thing is we have buttons from 1 or from 0 to 9. We have the operators, the normal ones. We also have the equals. We also have the dot. So what we're going to be doing now is walking through how we handle events which are generated from those buttons. First thing, as a rule with Action Listener, we say that we always have to register a listener with our buttons. So we have done the same from button 1 all the way to the very last button, and the last button in this case is this button for clear. That is what we have done as of now. Now next is handle the event, because we normally use what we call the event or event delegation model. So one part listens whether the button has been clicked, the other part handles, or rather we specify what is supposed to happen once that button is clicked. So that being said, we're going to create inside the body of the action performed method, we're going to create an object of the object class. Object is a class, and we normally say it's the superclass of all the classes in Java. I'm going to create an object, and I'm going to call that object SRC. What I'm going to do with SRC, I'm going to assign AE, the object of action event, calling the getSource method. The work of the getSource method is simply ascertain whether a certain button is the one that has been clicked or is the one that was clicked. So simply, let's begin this way. If the source of the event is being generated from this button called B1, for instance, do something. So what do we expect to do once B1 has been clicked? There are two ways of handling this. Action event, the parameter that has been passed in the action performed method, is a class. Now, being a class, it has several methods which we can use at our disposal. So there is an option of using the get action command method, or we can still use this option which I will present to you. T is the object of our text field. We're going to call it set text method. Inside set text, we're going to call what? Actually, I can do this simply for now. We're just going to add 1 because button 1 has been clicked, so write 1 on the text field. We can do this for 4 buttons first of all. So else if button 2 was clicked, write 2 on the text field. Else if button 3 was clicked, write the number 3 on the text field. Else if button 4 was clicked, write the number 4 on the text field. So let's just deal with the first 4 buttons. We see what is supposed to happen. Also, something else I would like to mention. For the text fields, the JText field class it normally handles any text within it as a string. That is why we are enclosing these numbers in quotation marks. So they are not really integers, but we will get to the point where we are supposed to convert them to integers or doubles actually. When it's the way it is, I'll just come here, I will compile the class, I will load the bytecode, and then we can just have a feel of how sorry about this, I don't know why it's not appearing all of it. So button 1, button 2, button 3 and button 4. Those 4 are the ones which we have enabled so far. Now in it, yes, it does what we expected, but let me just demonstrate something with the Windows calculator. When we click on button 1, 2, 3 and 4 continuously, it writes all of them on the text field. But ours has a single problem. It is deleting what was there before and writing the new character of the button which you have clicked. So to solve that, we can simply put it this way. I'll just go back to the source code. There is a set text which we have used to write to the text field, but there is also get text. So inside here, we're going to say, instead of fully deleting what was there prior, just call the get text method, and then since the get text method returns a string, or rather it's supposed to give us a string, also call the concat method. Concat is just concatenate, join together. So pick what was there prior, assuming before button 1 you had clicked something. So pick what was there and then join it to the 1, so that it just becomes one very long number. So we can do this for the rest. So if you'll allow me, I'll just copy. Then I'll add the opening and closing brace, so bracket, sorry. I'll do the same for button 3. Close that. I'll do the same for button 4. So we open that bracket and then we close it there. Currently as it is, it's able to do the same thing that this calculator from Windows does. So I'll do the same process. I'll compile, and then I will make an attempt to run it. The display, not sure why the buttons are not all loading, but it's okay. Now 1, 2, 3 and 4. Those 4 are the only ones which we have enabled. So continuously pressing will still continue writing the output on that text field which we have up there. So far so good. We can continue the same process and ensure that we have from button 0 all the way to 9. So those are 6 more buttons to go. So what I'll do, if you'll allow me, I'll just copy this and then I'll just paste it down here. So after button 4, we're supposed to have button 5 there. So 5 there. Alafu button 6 is coming up next. Then we have button 7 coming up next. Then, sorry, we have button 8 following up there. Then after button 8, I'll just copy this again. I'll paste them there. After button 8, we have button 9. And then finally we have button 0. So currently, we are able to write on the text field all those buttons 0 to 9. So we can just make an attempt to compile and then we run it again. There seems to be a slight problem in terms of delay when the buttons are being displayed. Anyway, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have all of them and we are able to successfully write those figures on our text field. Now, the next part is, what do we do when it comes to the operators? The operators are arranged on the far right. We have division, multiplication, subtraction, and then addition. They are arranged in that order. So what exactly do we do with them next? I propose this approach. I'll come at the class here. Actually, the variables are already declared. So I wanted to explain this bit simply. Right now, currently, we are making an assumption that every number we are dealing with is an integer, it's a whole number. But normally we don't make such assumptions. That is why in line number 11, I have declared several variables, 3 of them to be precise, that are of type double. Double means a number with a decimal point. So since we are not assuming anything, and we would like to basically pick a number, perform the computation, and then display the same or the result may be a number with a decimal point. Now, we don't want to assume. So let's start with A. A has been given or has an assigned value of 0 currently, because A is just a variable which I would like to use. Then we have this operator. It's an integer, a whole number. Let me put it this way. Once it comes to the operator, we are going to tag the operator. So once plus has been clicked, we give it a unique number, a unique integer, a unique whole number that is supposed to represent the plus, such that when we get to the other part where we actually perform the computation, it will be easier to track and follow through. So we'll come here. The operators from division, multiplication, subtraction and addition all have an event or a listener register. So we can just go right ahead and deal with them from here. So I'll just come here. Else if the source of the event is coming from this button that is called divide bd. That is the object that I used to create the button. So if the source of the event is coming from that button, what do we do first? Number 1, take the number that is currently there, because once you look at the calculator, before you click on any of these operators, you will have at least typed some number there. So first thing, pick that entire number that is there, because we expect the moment I click on plus or divide, since it's the first one, it's supposed to delete everything here, give us a blank slate so that we can continue now typing. So A is the double that we had declared up there. Use it to pick, now typically all text fields treat any input in them as a string. So we have to convert that to a double so that we can successfully assign it to this variable that is called A. So there is a class, we normally call it a type wrapper of the data type double. It's called a double with a capital D. That class has a method called pass double, P-A-R-S-E, pass double. The work of pass double is simple. Pick this input, convert it to a double, and then reassign or assign the same to the A, the variable that we had declared at the class level there. So call the getText method of the text field, because this one reads the current value that is in that text field, the current number. Convert that number and then assign it to this variable. Once that happens, it is possible for us to basically just display the operator. So we can call the setText method of our text field, and then we can just display that operator. The display is not a must, but it's important for someone to actually see it. Then once that happens, you remember we had created a variable. Let me just take you back up here. There is this variable called operator that has a data type of integer. We had said we are going to tag all our operators. So we can put it this way simply. If this this division is the one that has been clicked, take that variable that is called operator and tag the division by appending a value of 1. So it's just an easy way of doing it, but there are so many other alternatives. Let's follow this one first. We have tagged it. So the moment the double has been clicked on the keyboard, or rather on our buttons here, this not double but division, sorry. The moment this division has been clicked, the application logic will be aware that we have tagged it and we have given it a value of 1 as an operator. Then empty the text field by just calling the setText method, and then we pass an empty string to it. So currently that means our text field is completely empty. Let's see how this one works fast, operates fast, and then we will continue to the rest. So I'll just come here, allow me to clear this screen first. We will compile, then we will make an attempt to run it. So sorry about this, it has a slight delay, but something we are going to deal with. So 4, 5, 6, 1, 2, or 3, 2, 1. The moment I click on this division here, it will first pick this entire number and assign it to the A. Then it will write this symbol. Then it will empty the text field. So it has done it. But the only unfortunate thing is that writing the symbol and emptying the text field happens so fast that we cannot even be able to see it. I have generated an error behind the scenes. The error is simple because there is nothing to read. There is no integer that has been, or there is no number that has been read. Anyway, that's okay. So let me just clear this screen and then we come back here. So we will do the same for all our other operators. So I've just copied that, I'll paste it there, and then we say next is let me just confirm, division, multiplication, subtraction, and then add. So this is supposed to be multiplication. So I'll just change this symbol. I add the multiplication symbol. I'll tag it with a different number. This one will remain the same, but still the part where we pick the number is still remaining the same. Then subtraction. Pick the number. I'll change this to a minus. We will tag it with a different number, let's say 3, and then empty the text field. Then finally we have the addition. So pick the number, as write this plus, tag it with a different number, let's say 4, and then empty the text field. So currently all our operators and all our numbers are working, the buttons which have numbers, that is. The only thing remaining is what do we do when someone presses the equals button? That is the only thing remaining, and that is where now the computation or the calculation is supposed to happen. So I'll just come here, we deal with the equals button. So else if we'll check whether the source of the event is coming from this button called BEQ, the button for equals. If the source of the event is coming there, or is coming from that button, there is this other variable we had created called B. B is supposed to be a variable to pick the second number. So we'll just come back down here. Since the first number we have already picked it before we press the operator, now let's pick the second number before, or the moment we press the equals rather. So B will follow the same process, double. We call it pass double method, and then we convert whatever we're going to be reading from our text field, like that. So we'll still have to terminate that. If that is the case, we can come here. Now it is possible for us to do what we call nesting. Nesting, we can make it possible to nest an if inside another if. However, I would like to follow a different approach, because it's also possible for us to nest a switch inside an if. Switch case is still another conditional branch statement which you can use. So I'll just come here and I'll follow the syntax of switch. Switch has a pair of brackets and a pair of opening and closing curly braces. Inside these brackets, we will be checking a variable. So as long as the data we are going to be testing for is of type operator. Remember, let me just take you up here. Operator is an integer. So the kind of data that we're going to be ascertaining or checking inside the switch case is going to be integers. So we'll just do that. Let me just come back down here. So we normally put it this way. In switch, we use cases. So the first case is going to be case 1. Remember, we had tagged our division with this 1. So we are checking if the operator that was clicked is actually a division. That is what we are ascertaining here. If that is the case, then pick the variable that is called result. It's of type double as well. Assign A divided by B, probably we can still do the same, not do the same, but we can call the set text method of our text field. Now typically it would be simple because we would just have to pass that result up there, but now we have a slight problem. Let's just do a simple demo or simple example when we are using the case of division. Simple example, but this is the point that the error is going to emanate from. So I'll just do a compilation, and you can actually see the error emanates. It's actually a syntax error. So it's telling us we have incompatible types. It is impossible for you to convert a double to a string. Now, two options. Option A, we can convert this result to a string so that we can be in a position to display it on our text field. Option B, we can simply do this. Since it is expecting us to pass a string, we can pass an empty pair of quotation marks, and then we concatenate the result. So it will just be displaying that number, but the number is part of this entire output or display, which is treated as a string typically. So if we do compilation again, solves our issue. We can make an attempt to run it, and we just see how it looks. There's a slight delay in the buttons being displayed, but don't worry, we're going to deal with that in a moment. So we can do something like what, 81 divided by 9, and then the moment I press equals, it is going to go do the division and then display the answer for us, and the answer being 9.0. So far we have dealt with the first operator. The procedure or the methodology is still the same when we go to the other operators. So if we just come here, there's actually no need for me to copy the case, because I can just do this. Case 2, and case 2 was what? 2 was division was 1, 2 was multiplication. So if it's a multiplication, take result, assign A multiplied by B, then just display. We call the set text method of our text field. We can append that empty pair of quotation marks, concatenate it with results, like that. Switch case normally has one issue. We normally say it is fall through, meaning if the condition that we are testing for will be found in the first case, it will still continue executing in the other cases. So normally, to stop it from continuing, we just add the break keyword here. Sorry, just a moment. Just break. Break is stop execution. So we do that for this other one as well, like that. Then we move on to case 3. Case 3, I think, was subtraction. Sorry, I was supposed to be checking it here. 1 was division, multiplication was 2, 3 was subtraction, and then 4 was addition. So I can actually just copy these two to make my work easier. I'll just paste them there. This is supposed to be case 3, this is supposed to be case 4, this is supposed to be minus there. There's nothing else we need to change here. This is supposed to be an addition there. I believe we are through. We can actually test all the operators now, and we see whether our calculator works as expected. So prior, the only thing we have not done together is creating the user interface, and that's why it's bringing some of these challenges, a delay in display. Anyway, 7 times 7 will give us 49. There's this button of clear. There's clear and there's delete. But let me first deal with clear. Clear is supposed to empty everything here. So when we click on clear, just delete everything that is there. So we'll just come here. Let me confirm something here. So clear is BCLR. So this else if ends where? Ends here, I believe. Let me see. Yes, it ends on this brace. So I'll just come here and add another else if. Normally, so that you don't get lost, we add comments. So we can label this one as end of switch block, so that it will just notify us that we have come to the end of switch. So if the source of the event is coming from this button called BCLR, we just want to do something simple, clear the text field like that. Once the text field has been cleared, we can be able to test now all of them, since we have a way of clearing it. Again, it still has a lot of challenges when it comes to display, but 5 plus 2 gives us 7, so we can clear. 6 minus 3 gives us 3, we can clear that again. What else have we not tested? Multiplication, 6 times 6 gives us 36. We had tested the division, 9 divided by 3 is going to give us 3. So I believe we are through with the calculator. We are through with the calculator, most of the functional areas anyway. We are through with most of the functional areas. Now, as you can see, it's something very basic, something very simple. We're using a library called Swing. It's a library, it's one of the initial libraries that came with Java or shipped with Java. Obviously, we have progressed, or we have changed quite a few things. And what I would like us to do next, in the next session probably, we're going to be talking about the same but done in a different library we call JavaFX, but that one will come next time. So for today, that is all. We can call it a day. Thank you.